Good day, class. So it's Sir Gerald again, Sir Capistrano. For today, we will be talking about alkenes and dienes. Actually, on our past, in the past videos, we actually talked about alkanes, isomers, reaction mechanisms, and a lot. So in that, we'll be jumping into another functional group, wherein for today, we will be actually talking about organic compounds that have functional groups. And by functional groups, as you may have remembered, these are the sites or these are the parts of the molecule wherein a reaction occurs. So in that, we will be having that kind of luxury wherein unlike alkanes, we don't have specific sites for bonding or chemical reactions. So in alkenes, we have the double bonds in which we will be having those reactions. So in that, let's start the discussions. So alkenes and dienes are actually what we call unsaturated aliphatic hydrocarbons that contain one and two carbon double bonds. So one double bonds or one carbon to carbon double bond for alkenes and two carbon carbon double bonds for dienes. So in that actually when we talk about alkenes and dienes by unsaturated, the saturation that we are talking about is the number of hydrogens. So unlike alkanes, so last time we have alkanes in which the general formula for alkanes will be CnH2n plus 2. So in comparison with alkenes have a chemical formula of CnH2n. Meaning to say, if we talk about alkenes has far less hydrogen atoms than alkanes due to the presence of two additional hydrogens for alkane. So, saan ba napunta yung additional na alkanes na yun? It's because of the double bond. It's because of the double bond. So, if we talk about, let's say ethane. So, if we have ethane will have this structural formula wherein we have a single bond from carbon to carbon and we just fill up the remaining valence electron or we pair up the remaining valence electron to hydrogens. So this is an aliphatic hydrocarbon, meaning to say we have here only carbons and hydrogens. But when it comes to alkenes is characterized by a double bond. So for ethene, we will only have two additional bonding sites for hydrogen, meaning to say we will only have two hydrogens here and another set of two hydrogens here. So, doon napunta yung nawawalang plus 2. Okay? Uh, the site for the bonding of two additional hydrogen is actually used for the double bond. So basically, when we talk about alkanes, kung maalala nyo, we have here that sigma bond. Okay? So for alkenes, we actually have here a sigma bond. And we have here our pi bond. So, ano bang ibig kong sabihin dito? As you may have remembered, when we talk about sigma bonds, if we have here our carbon having four sides of valence electron for bonding, as you may have remembered, sigma bond is actually the overlap between two orbitals of this is our sigma bond of two bonding sites or the overlap of the electron kung saan man gumagalaw yung electron natin. So when it comes to pi bond, what actually happens is we will have here, aside from the sigma bond, we will have another site here. Actually, this here is more circular. Paikot siya papunta rito. Okay? So, that site is actually for sharing electron. Yun yung ating site na tinatawag nating pi bond. So mamaya, we will have other discussions regarding this. And also for the cyclic analogs, so for cycloalkenes, we actually have the chemical formula CnH2n, okay? And for the cycloalkenes, we have the formula CnH2n minus 2. So, saan ulit napunta yung dalawang hydrogen na yun? Same answer with the alkenes. Yan ay na-i-designate para dun sa ating pi bond or dun sa double bond. Okay. So in that, actually, let's move to the structure and nomenclature of alkenes. Kasi sabi natin last time when we are discussing functional group, we will be talking about the physical properties, the structure, and the nomenclature of those functional groups. So in that, we have the structure and nomenclature of alkenes. To begin with, let's talk about the how we are naming uh, alkenes. And after that, we will actually be seeing the structures of these alkenes. So first things first, nomenclature of alkenes actually follows the same rules for alkanes, wherein we will be taking note of the parent chain, or it is the longest chain with the highest number of branching. And after that, we will position or hahanapin natin yung position ng ating mga substituent or mga tinatawag nating side chains. So, and then we will be giving the lowest possible number or lowest possible positions for those side chains. So, halos ganun din yung sa alkenes natin. So, as I note here, alkenes are actually named using the same rules as alkanes. So, for alkenes, ang kaibahan lang, we will be looking for the parent chain that should contain the double bond. That's one. Pero same process. We still need to look for the parent chain. And by parent chain, it is the longest chain of carbon that we can find in the organic compound. And for in that, the parent chain is named by changing the "-ane" ending of the corresponding alkane. Meaning to say, if we have propane and we see a double bond, it will be propene. We will just indicate the "-in" instead of "-ane", and we will be indicating the position of the double bond by the lowest number possible. So I will be providing some example later on. And last, additional rule when we are talking about alkenes, and the carbons bearing the substituent are also given the lowest number possible, or lowest position. But the double bond takes precedence. Meaning to say, if we have double bonds in side chains, uh, the double bond must first contain or must be assigned the lowest possible number, and then saka lang yung mga nasa side chain natin or yung mga tinatawag nating substituent. So for examples here, we have this compounds. I have here the condensed and the uh, uncondensed form of the formula. So for this, let's talk about this first formula, or this first chemical formula. So in this is just a long chain, a straight chain. Wherein in our straight chain we have here one, two, three, four, five, uh, five carbon compounds. So based on our discussion, this is actually, if we don't have the double bond, this will be pentane because five penta. So in here, we just change the from pentane, we just change this "-ane" to "-ine", so we will have here pentene. Okay. Okay. So in this pentene, we just need to look for the lowest possible number or position of carbon bearing the double bond. So I have here two carbons having the double bond, this one and this one. So if we start from left to right, we will need to check kung alin ba yung pinakamalapit. So I already numbered from the numbering from left to right. Let's try from right to left. So we will have here 1, 2, 3, 4, 5. As you can see here, the lowest possible number is 2 instead of 3. So in that, we will be naming the double bond, or we will be signifying the position of the double bond using 2 instead of 3. So we will have here 2 pentene. Okay. So same goes for this type of the other example. So we just need to look for the parent chain. So in that, actually, we have here a methyl. So pwede natin gawin. It can be 1, 2, 3, 4, 5, 6, 7. Same for this one. So this is 1 plus the 6 carbon atom. So we actually have here, if we don't consider the double bond, as I said, we have 7. So that will be heptane. Okay? We just need to change that in to in. So we will have here heptene. Then we just need to look for the lowest possible number for our substituents and the double bond. So first, we have here, if we consider this one, let me just write that, this red line here. If we consider this as our parent chain, that one, so what will happen here is we need to assign numbers to this line or this parent chain. So it can be 1, 2, 3, 4, 5, 6, 7, or it can be 1, 2, 3, 4, 5, 6, and 7, having that metal group there. Okay? So in here, since the double bond takes precedence, as we can see here, if we start from the left side, left to right, as you can see here, the double bond or the lowest possible position for the double bond will be 4. And if we start from right to left, as you can see here, the lowest possible number will be 3. So we will be using that, okay, for the heptene. So what of the methyl? So in that, if we start from right to left, so we have here 1, 2, 3, 4, 5, 6. The position of our metal will be 6. So in that, we will be having our 6 dash methyl dash, because we have here 3, right? So we'll have here 3, and we'll be having the septene. So basically, we will have here 6 methyl 3 heptene, wherein our double bond, or the lowest possible number or position for our double bond will be 3, and the position for our metal will be 6. Okay, so hopefully that's clear. So let's have here another example. I want you to try to name this compound. So go ahead, you may pause the video and look if you can name this compound. Okay. So in here, actually, class, if we look at the longest chain will actually be 8. So let's use another color of the pen to represent that. So the longest, or uh, longest chain could actually be 1, 2, 3, 4, 5, 6, 7, 8. But in that, actually, we will be not considering this chain because we have here double bond. So you can see here, due to that double bond, makipansin natin, hindi kasama dun sa longest chain yung ating double bond. So in that, hindi natin siya pwedeng i-consider. Okay? Hindi natin pwedeng i-consider yung longest chain na to as our parent chain due to the presence of the double bond. So in that, we can actually start from the metal groups. It can be this one, start from here or here. Because it's simply because we need to consider or we need to include the double bond. So in that, we will actually have let's just use this one. So let's consider this as one. Then we have here two, three. So let's just check kung saan ba tayo pupunta, kung ano yung pinakamahaba. If we have here three, then we have here four, five. Either of this will be six. Okay. So if we go downwards, we will actually have here four, five, six, seven. So in that, we will be actually considering this one as our or this chain as our parent chain. Okay. So we have here the substituents. So we have here a metal group. Let's change that color so we'll not be confused. So we have here a metal and this one. And as you may have remembered, this is actually counting this off. This is actually an isobutyl. So for the positioning, as we can see here, we have here seven. So we actually have their heptene. And for the methyl and the isobutyl, since iso should be considered or should take precedence or in alphabetical order, we have here I and in comparison to met. So meaning to say we will have here, so we have here one, two, three. So we have here three isobutyl. Then we have here one, two methyl. Then we have, let's give the lowest possible number or position for the double bond. So this will be two. Then, since this is 7, heptane, that is heptane, or for alkene, that will be heptene. Basically, this compound is what we call 3-isobutyl 2-methyl 2-heptene. Hopefully, you got that right. So, moving on to other types of alkenes, which is actually diene. So, by its name, diene, uh, oh, cycloalkenes pa lang pala. So, sorry about that. So, for that, we will be talking about the sizing positions for cycloalkenes. So, by cycloalkenes, we will be giving the lowest possible position for the double bond. So, meaning to say, the double bond, correction, that is double bond, is always between the first and the C1 and the second carbon. So, the substituents or the side chains are given the lowest possible number. So, in that, if we have here this one, as you can see here, we have here 6 carbon atoms attached in cyclic analog. So we have here 1, 2, 3, 4, 5, 6, and we have here this double bond. So in any case, since this is in cyclic or it is a cyclic compound, we can actually name this as one. Also, we can name this as one. It won't matter, okay? Because we have here or we don't have any side chain here. So in naming this compound, we simply name this as cyclohexene. Why cyclo? Because it is cyclic. Hex, because it is six carbon atom or molecule. And we have here in because of being an alkene or having a double bond. So when it comes to this chemical formula or structural formula, we have here a double bond and a metal group that is attached to our cyclic compound. So we have here a double bond, meaning this is an alkene, or to be specific, a cycloalkene. So in that, as the definition says, we will be giving the lowest possible number for the substituent. So basically, since our double bond can either have the first or the second carbon position. So what can happen here is this can be 1 and this can be 2. Okay? So meaning to say, we will have here 1 dash methyl cyclo. No, no spelling. So we have here cyclohexene. 1 being the position of the methyl, cyclo being a cyclic compound, and kulang yung sinulat ko, hexene, hex because 6, and in because of the double bond. And lastly, so for this one, we actually have here another metal group as our side chain or the substituent. And we have here a cyclic compound with 6 carbon atoms and a double bond. Since we are giving the lowest possible number for our side chains or our double bond per se, we cannot actually name this as one or position number one. Why? Because if we go clockwise, this will be position two, position three, 4, 5, and 6. And as you may have remembered, we need to give the lowest possible number for our substituent. And we give it the largest possible. So hindi rin naman pwede na the other way around if we name this as our 1. Because if we name this carbon as carbon 1, we can name this as 2, and we will be having this one as carbon 6. That will be depicting the definition that our double bond must contain the first and the second carbon atom. So in that, actually, what we can do here is name this one as our first carbon, having this one as our second carbon, and having this one as our third carbon. So in that, the double bonds or the carbon bearing the double bond will have the lowest possible uh, numbers, which is 1 and 2, and the substituent also will have the lowest possible number, which is 3. So in that, we will be having 3 methyl, sorry, it will be 3 methyl cyclohexene. Okay? 3 being the position of the metal compound, methyl because of this metal, cyclo because of the cyclic nature of the compound, and hex being a 6 carbon molecule, and in being organic compound bearing the double bond. So that is how we name our cycloalkane. So you can actually try to name this one, though it is somewhat impossible to have this because of the instability that may occur due to the presence of the double bond and being cyclopropane, and we have here our CH3. So you can try to name this. I will be giving you some time. You may pause the video. Okay. Having that, this is actually what we call a one methyl cyclo, sorry, no space, cyclopropene. Though it is somehow impossible to have this type of compound, or highly unlikely, not impossible. Okay? So, in that, hopefully, yeah, naiintindihan yung mga pinagagawa natin. So, in that, let's move to die-ins. So, by die-ins, from the word itself, die, meaning two, and ins, as representative of alkenes. So, nomenclature of die-in actually accounts for the position of the bonds and the lowest possible position given to either of the double bonds. So, in here, actually, when we talk about die-ins, we will be having organic compounds that has two double bonds. By two double bonds, we will have here uh, dalawang carbon to carbon double bonds. So in die-in are actually classified according to the arrangement of their double bonds. So basically, we have three types of die-ins. We have the conjugated die-ins, we have the isolated die-ins, and the accumulated die-ins. Although hindi ginagamit yung classification nila para dun sa naming nila, conjugated, isolated, and cumulated die-ins actually, the names present the structures or the properties of the die-ins, which we will be talking about later when we talk about or discuss the reaction mechanisms of die-ins, which will be on a next video. Okay, so in that, let's look into the conjugated dienes. So by conjugated dienes, these are dienes with double bonds that alternate with a single bond. So I have here two examples. We have here 2-methyl 1,3-butadiene, and we have here 2-methyl 1,3-cyclohexadiene. So let's first start with the butadiene. So by buta, we all know, but by but, that means four, meaning to say we will have here we will have here one, two, three, four. Ano ko nasabing four yan? Each of the endpoints of the segments is one carbon atom. So we have here four. Okay? Then, sabi niya, we have here one, three. So I have here a double bond that is in location one. So we have here one. So if we use that as our first carbon atom, so we will have here one butene. And if we add another one in three, so we have here one, two, three, meaning to say we will have here this double bond here. And we have here two methyl. Okay, so we'll have here two methyl, that's one, this one, and we have one, three butadiene. So as you can see here, this is one example of what we call conjugated diene. By conjugated diene, two double bonds alternate with a single bond. So we have here single bond and another double bond. So that is why we call this, or we call classify 2-methyl butad 1,3-butadiene as a conjugated diene. Okay. So how about 2-methyl 1,3-cyclohexadiene? So cyclohex, meaning to say we have 6 carbon atoms in a cyclic analog. And we have 2-methyl. Okay. Pero dun muna tayo sa 1,3. So, as we may have remembered from the cycloalkenes, the double bonds must have the first carbon 1 and carbon 2. So if I construct or write a double bond here, it means that this one can be carbon 1 and this one can be carbon 2. So in that, let's have this one as our carbon 1. So meaning to say this is carbon 2 and this is carbon 3. So we will be positioning this double bond here. So and our methyl on our carbon 2. As you can see here again, we have here the double bond, single bond, and our double bond. So again, this is a conjugated diene. Okay, so let's move to the other type of dienes, which we call isolated dienes. So by isolated dienes, these are dienes having two of the double bonds separated by one or more than one single bond. So I have here an example. We have here a 1,4 pentadiene. So by pentadiene, I have here one carbon atom. So I have here, let's just add the hydrogen later. One carbon, two, three, 4, 5. So I have here 5 carbon atoms. And diene, meaning to say we have two double bonds and one is positioned at number 1 or carbon 1. And if we took this as our carbon 1, we will have here this bond. And counting off, we will have here 1, 2, 3, 4. So this is carbon 3 and carbon 4. So meaning to say we will have here the double bond here. So we'll have there the 1,4 pentadiene. We just need to add the carbon, the hydrogen atoms. So we already have here uh, two bonds. So I have here two. We have here one, two, three. So I have here an H. We have here, so we have here H and another H here. And we have here one, two, three. Meaning to say I have a hydrogen here and our H there. Okay. So that is our 1,4 pentadiene. As you may see here, the double bonds are actually separated by two single bonds, making this compound uh, an isolated diene. So again, for the other example, we have here 3-methyl 1,4-cyclohexadiene. So cyclohex meaning again, we will be having a carbon compound that have four, like six carbon atoms. Then I have here a methyl and a 1,4. So again, same scenario as our conjugated. I will be positioning the double bond or the double bond on the first and second uh, carbon atom. Then we'll just need to count four. So we'll have one, two, three, four. We'll be having that compound there. So I have here four. Then we need to position the methyl. So for the methyl, it can actually be here or it can be here. Why? So, kung titingnan nyo kasi class, pag binaliktad natin yung numbering, ang mangyayari, kapag nilagay natin itong 1, itong 2, we'll have here 3, 4, 5. Also, ganun din mangyayari kapag dun sa kabilang side. Sorry, nabura ko. So, we will have here 1, 2, then we'll have there 3. So, ganun din yung pag dun sa taas. Okay. So, in that, as you can see here, our double bonds are actually separated by two single bonds in either side. So, as you can see here, we have here our double bond. We have here single bond, and double bond. Okay? The other way around, ganun din yun. So we have double bond, single bond, then our double bond. Okay? So making this compound an isolated diene. So for the last one, kinuha na natin yung alternating. We have the alternating between double bond. Then we have the isolated in which we have more than one single bond, yung isolation nila. So in that, we actually have what we call the cumulated diene, or what we also call allenes. So by allenes or cumulated diene, these are dienes having two double bonds sharing a carbon atom. So how does it look? So we have here a 1,2-butadiene. By butadiene, as you may have remembered, this will look like just four. We will have here four carbon atoms. One, two, three, four. And one, two. Meaning to say we have double bond about the first carbon. So if we have here as our first carbon, or baliktarin natin class, baka iniisip nyo lagi dapat left to right. Hindi po, pwedeng right to left. If we characterize this as our first carbon, we will have here a double bond, okay? Because of the one. Then we have here the two. So if this is one, this will be two. So we'll have here this one, okay? Then that's single bond there. So, as you can see here, the double bonds actually share a single carbon. So, in that, we have here our hydrogens, we have here our hydrogen, and we will have here our three hydrogen. So, that will be our 1,2-butadiene. So, for this one, we have here a penta, hindi na siya cyclo. So, we have here a pentadiene. So, what can happen here is let's just draw the penta first. So we'll have 1, 2, 3, 4, 5. It's 1, 2, 3, 4, 5. And this time, let's first locate the methyl. So as the name states, it is located at carbon 2. So if we consider this as our carbon 2, we can attach the methyl there. We just write the CH3 there. So we know that that is our methyl group. Then we have here the 2, 3. As you may have remembered, 2 yung methyl. So meaning to say this is 2. So our first double bond will be here. Okay. And 3, pentadiene, meaning to say this is 3. So we'll have here this double bond. So again, we have here accumulated diene wherein two double bonds share a carbon atom. Okay. So to end this video, let's just talk about the last part of the basics when we talk about alkenes and dienes. And that is the physical properties of alkenes. So in here, actually, when we talk about alkenes in comparison with alkanes, alkenes actually have what we call a slight dipole moment, not unlike alkene, due to its loosely held pi electrons, or wherein that pi electrons is what we call the overlap uh, of the location of the electron cloud na nagkakos ng tinatawag nating double bond. which can be easily pushed or pulled, though na nagko-cause nung tinatawag nating slight na negativity due to the presence of the those electron cloud dun sa ating pi electrons. Though alkenes are still non-polar due to the low magnitude of the dipole moment. Kahit na sabihin natin may slight na polarity or dipole moment due to that pi electron, as you may have remembered, as you may have remembered, if we have here our carbon compounds, we have here the sigma bonds, which is the overlap between those carbon atoms. And as you may have remembered, we have there two electrons. Tapos i-add mo pa yung overlap dyan sa ano natin, sa sigma, yung ating pi bond dito, meron ulit silang dalawa pang electrons. So that four electrons actually introduce what we call that slight dipole moment. But basically, that slight dipole moment is too slight for the alkene to be polar. Meaning to say, if we mix alkenes with water, hindi pa rin siya maghahalo totally, or hindi sila magiging miscible in that sort because of the low magnitude of that dipole moment. So somehow, alkenes have similar properties with alkenes. They are still insoluble in water. They have lower molecular weight. Alkenes are gases at room temperature. It is again due to not much intermolecular forces that held the molecules together. And also, alkenes are insoluble in water but soluble in nonpolar organic solvent. So some nonpolar organic solvents are some esters or no ethers uh, and the like. Also, alkenes are less dense in water. Less dense in water, meaning to say if we mix alkene or the liquid alkene with water, the alkene will behave as oil mixed in water. It will be floating above the water. Okay? So, in that, I have here some representative alkenes starting from ethene because there are no methane. Paano tayo magkakaroon ng double bond kung iisa yung paano tayo magkakaroon ng carbon to carbon double bond kung iisa yung carbon natin, which is meth. So I have here some representative alkenes. We have here ethene, propene, 1 butene. We have here 1 pentene, and we have here 1 hexene. Hopefully, alam niyo kung sino yung mga sinabi ko. Sige na, ilagay natin dito. So basically, we have here ethene, and we have here propene. Some of you may be thinking, sir, why do we don't uh, include the position for propene? Kasi kung mapalagay man siya rito sa kabila or dito sa side na to, kung kinonsider natin tong 1, 2, 3, magiging 1 pa rin siya ano, pag dito siya nagkaroon ng double bond. So still it's 1 propene. So we don't need to include the position of the double bond. So when we say ethene and propene, automatically the the double bond is located at the first second carbon. So in here we have here 1 butene. Bakit siya 1 butene? We have a double bond and we have 4 carbon atoms again, and uh, the double bond is located about the first or bonded on the first carbon atom. And again, we have here 1 pentene, same case. But for now, for this case, we have 5 carbon atoms. And lastly, we have here 1 hexene, same explanation. So in here, class, when we talk about ethene, propene, butene, pentene, and hexene, we can actually compare this to some of the alkanes having the same number of carbon atoms, and some of them actually have far less less, let's see, some of them has actually a lower boiling point when it comes when in compare in where when we compare them into the representatives of alkane. Bakit kaya? Kasi as you can see here, class, we still have here this non-polar compound, meaning to say, besides the slight dipole moment that we have for these alkenes, mas nangingibabaw pa rin yung tinatawag nating nandun pa rin yung tinatawag nating London dispersion forces or yung tinatawag nating van der Waals forces. And due to the lesser number of hydrogen compounds or hydrogen atoms per se, in this organic compounds, mas nagiging maliit yung tinatawag nating surface area. And as you may have remembered, that surface area is responsible for the intermolecular forces of attraction uh, each between organic compounds, or by organic compounds I mean alkane and alkene. Dahil dun sa less na London dispersion forces, mas mababa yung ilang physical properties nila kasi mas mababa yung attraction na mangyayari. For example, if we compare propene to propane, propane actually have, so dito tayo. Kung propane, we have a boiling point which is negative 42.1, and propene has a boiling point, lagay ko dito ha, BP, have a boiling point of negative 47 degrees Celsius. And for those na hindi nalilito sa negative numbers, mas mababa ang negative 47 kaysa sa negative 42. As you can see here, just mean that the intermolecular forces between the alkanes having the same carbon atoms with the alkene actually have yung alkanes natin ay may higher intermolecular forces of attraction. Kahit na kinonsider natin na uh, mas ano, mas may dipole moment yung ating yung ating alkene. But when it comes to butane, mas mababa na yung sa butane. For butane, we have here negative 6.3 degrees Celsius. When we compare that to butane, that will be negative 0.5 degrees Celsius. And for pentane, pentane has a boiling point of 30. Balik na naman tayo. It has a boiling point of 30 degrees. Still air or in gases, in gas form, in room temperature. And pentane actually have a boiling point of 36.1 degrees Celsius. So again, medyo malabo man yung trend. Ano? But when it comes to larger larger alkanes, wherein we have here one pentene and pentane, nagkaroon actually ng slight difference wherein mas mataas na naman yung intermolecular forces ng pentane kaysa sa pentene. And for hexane actually, one hexane has a boiling point of not negative, that is 63 degrees. And hexane have a boiling point of 69 degrees Celsius. So as you can see here, alkane again has higher boiling points than their alkene counterpart. So, bakit? It's because of the lesser number of hydrogen atoms. But in some point, pwede kasing mag-take precedence yung ating slight dipole moment. So, that may explain what happened in butene in comparison with butane. So in that, I will be ending this video. So you can just expect another set of video wherein we will be talking about reaction mechanisms of alkenes, which are actually puro addition reactions. But anyway, uh, I'll see you in that video. Bye.